So we're going to go through concept of abstraction, data abstraction, abstract data types. Abstract data types, does it ring a bell? Which course? Data structure. We spent so much time on the data structure, if you remember, in the data structure course, explaining actually what is an abstract data type, what's the difference between abstract data type, and how we can implement different, we have different implementations. So today we're going to go through it a bit to refresh your memory, and then we're going to see more like practical differences. For example, which languages support encapsulations and all of these kind of things and see the difference between few programming languages when it comes to the abstract data types. An introduction, we rarely know the right algorithm or the right data structures when we start a design project. And even after taking the data structure and algorithm course, we're still doing the same thing. We jump right away when we get an assignment, we start programming, and then we start figuring out, oh, no, I need a better algorithm. Oh, no, I should have used this array instead of linked list. So we're not actually always going step by step. But we often have to go back and change our code. Often we don't even know what the user wants, the requirement, until they see a prototype. Often we don't even know where the performance problems are until we do the test cases. And sometimes we just want to change the design and come up with a simpler algorithm. So how can we solve these problems, right? So how can we do that? Usually, the primary trick is to use data and algorithm abstraction, okay? Now, what are the the principle of this way is that don't code in terms of concrete representation that the language provides. That means, let's say you're building something in Java, don't right away just jump and start using Java libraries and all these things. We have to think first about our needs and how we can make this easier to work with. What are we focusing so far on when it comes to design things, readability, maintainability, reliability. So when you're keeping these things in mind, the design, even when you're designing, like not designing the language, even if you're designing your program, you want also to keep these in mind, correct? So do code with high-level abstraction and mind that fit the problem domain. And then we want to implement the abstraction using a well-defined interface and different implementation. We're going to cover this step by step. Now, Dr. Barbara Liskov, in 1973, actually, she's the one who worked so much and introduced the basics of data abstraction. And actually, in 2008, she won an award based on all her work. So that's why you're going to see that starting from 1980, all the programming languages after that, they start always using the abstract data types. So it's because it was introduced in the 70s. And if you go on her Wikipedia, she has a very, very beautiful story. We didn't have time to go through it, but actually she was maybe the first woman to even go and pursue math. Back then, women weren't even allowed to go in the university to do math. They can do other things in the 60s. And this is not like in the 1800s. These are the 1950s and 1960s, unfortunately. So it has a beautiful story. The background is math, bachelor and master's in math. And then she went to computer science and did her PhD. And it's funny that, as I always tell my students, is usually most of the algorithm that we use in computer science is developed with mathematicians that they're interested in computer science, because most of the stuff is actually have the math base. Now, if we want to go with the concept of abstraction, before even going to the data abstract type. So what is an abstraction? Abstraction is a view or representation of an entity that includes only the most significant attributes. So if I'm saying, okay, what is the abstraction of, I don't know, your smartphone, you're going to tell me this interface, these most important thing for me, that's the abstraction of the whole smartphone. Even though if you open it, there is so much more details, complex stuff in it, but in an abstract way, that's this thing that you hold in your hand. These are the kind of the abstraction of the idea of the smartphone. Now, the concept of abstraction is fundamental in programming and computer science. And as we said, nearly all programming languages support process abstraction. And in the 1980 onwards, all the programming languages designed to support data abstraction. Now, I took 2 or 3 slides from the data structure course. The students who took the data structure course with me, maybe they will remember these analogy that I'm going to use, but it's good to refresh our memory to understand what is an abstract data type. Again, when it comes to abstract data type, there is 3 main things that we're going to we need to define. What are they? What are these 3 main things? Michael? Operations, which will be what? Like the methods, all of these kind of things. So you need to know, I'm designing an application. I need to know this application has to do actions, has to do operations. What else? It will do operations on what? Based on what? Data, correct? So we need data, we need operations, and then also it needs to be able to handle errors. So these are the main 3 concepts when it comes to abstract data type: what can be stored in the ADT, what operations can be done by the ADT, and also the error conditions. So if we want to take an example of this, and we take the ADT modeling, a simple stock trading system. Okay, so the application is a stock trading system. In this case, what would be the data you can store inside this system? Is that
Stock transactions?
exactly? So that means what? If you want to sell stocks, so this is operation like sell, but technically is the stock transaction as a data, buy, sell orders. So the orders. Operations can be, as I mentioned, what? I want to buy a stock, I want to sell a stock. What else? I want to cancel a transaction, for example, correct? So there is many things that can be fit here. But one other thing that you need to include for this to be a good the abstract data type is the error. What would be some error handling in this case in a stock trading system? He said.
If there is a buy order or a sell order which can't be fulfilled at the given price.
Exactly. Let's say if you've dealt with stocks before, sometimes a few minutes will make a big difference. You want to try to buy something and then someone like these stocks are done or the what? Because you put an order based on a specific amount of money, correct? What if this stock have a higher price now? So you need to be able to handle these things, correct? So error condition, buy, sell, non-existent stock, cancel a non-existent order, for example. So you get the idea. Now, what is the benefit of having different abstract data types which are separate from each others? Okay. Usually, the most beneficial thing is that these things are independent. So if I change something, it's not going to affect the other one. Okay, so let's see an example. So we change a part of the code, example function, and the overall program still works fine. But what do you need to interact with this? So let's say, again, I have my phone, my smartphone. Under the hood, it's so complex. There is, I don't know, microprocessors and all of these kind of things. But how are you able to interact with this based on what? If you look at your phone, what do you use? Each time you want to take a photo, do you open the screw, go to the microprocessor and press stuff? You use what?
Camera app.
Okay, so this camera app can be what called formally an interface. Okay, so we're going to use interface to be able to access this. So let's see this. So here, this is the abstract data type here. Okay. So that's the public function, private function. We're going to talk about all of this. Now, these are the data structures. So I'm creating something in the memory, in the program, but this can be created using an array or a linked list. So I can call either of them, and both will do the same thing for me, and both they are going to have the same interface. So let's take a more practical example just for you to grasp the context is what is the famous car engine example from the data structure course. Who remembers this? Michael. So, who drives a car? Who owns a car? Very good. Okay. So let's say we have Toyota, BMW, Mercedes, Hyundai, whatever. We all manufacture cars. If I ask you, let's say, Michael, you raised your hand. What car do you drive? Ford. Okay, so if you want to drive a BMW, are you able to drive it? Why? It's a different company. It's a different manufacturer. Different engine, actually.
Same functions. You press the gas, it goes, press the brake, it stops.
Okay. So technically, even though it has a different engine, correct? The engine of a Ford is different than the engine of a BMW, different engine. And what is the main difference usually? For example, in a Beamer, what will happen? The engine will be more focused, let's say, on speed. And the other manufacturer, I don't know, Toyota or something, it will be more on gas efficiency. So there is some differences, right? Or lots of differences between the car engine, which is the main part of the car. But if I know how to use or how to access this Toyota car, also I know how to use the other car. Why? Because as Michael said, here I have the same interface because the car is an abstract data type. The engine is the data structure. So the car is an abstract data type. So when we have one abstract data type, it will have the same interfaces, which is what? A wheel, gas, brake, these are the same. But inside this abstract data type, I can design a car using a BMW engine or use a Toyota engine or whatever. So you got, I'm sure that you get the idea now. So car engine, what is the interface? We can turn the engine on, off, accelerator, brake, all of these will be the same for all the abstract data type. And then we can replace the engine of a car without another one, and the car will still work fine with the same interfaces. Now, unless you have a hobby, mechanic and stuff, but do you usually work with the engine? Do you open it and you fix stuff in it and stuff? No. Who have ever dealt with a dealer? So what happens usually when you buy a car from a dealer? They are so precise to a point that they will tell you, even if you change the oil sometimes outside of their dealership, like let's say it's a Hyundai dealership, even if you change the oil outside, they say, okay, we're not responsible, your coverage is not going to work, or you have to deal with it yourself if something bad happened to the engine. Correct? You will lose what's called the warranty. If I want to transform this into a programming design issues, why would the dealer tell you that you're going to lose your warranty, for example, if you play around with the engine?
Because they don't know what you're doing, even though what you said you're doing might be normal.
Good, very true. And also, it will make their job harder or easier if you play around with the engine? Harder. Why? They have specific things that they design this engine. So they know, for example, if there is an issue with the brakes, I'm going to check this part of the engine. Correct? But let's say you open this engine, you play around with it, and now they have to track things. This is what? Is this readability? Or what? Which issue is this? Is it readability, reliability, or maintainability? Think a bit. Readability, we don't have readability here. Reliability or maintainability? Misad?
Maintainability.
It's mainly maintainability. Why? They want to maintain this engine, right? At the best way, they want to maintain it. If you play around with it, if it's open access, anyone can play around, it's going to be very hard for them to what? To track the issues. But when they encapsulate this under the hood and you cannot touch it, you can only play with the interfaces, the wheel and stuff. If there is an issue, it will be able easily to maintain this engine for you. Okay, now what did they do when they packed everything in the engine and put it under the hood? It's a hidden information, right? So that's another very important aspect of abstract data type, is that modularity, which is the information hiding. It's one of the main aspects. We want to hide the important information. No one will have access unless we give them access to this information, correct? For example, if we take a more programming example like a stack, I want to create a stack. Now in Java, you can create what? A stack function using an array or a linked list stack function. Both of them, they will do the same thing. How can I access both of them? It's going to be stack.push. If I define my stack as an array stack or as a list stack, both they are going to work. It's the same interface. These array stack and list stack, they are hidden in one of the libraries, one of the classes. It's hidden somewhere, correct? A more concrete example would be not even this, on a lower level. Imagine the double or the int or the float that you can change it. You can go and then I want the double to act to understand strings. If they allow you to do this, you're going to, if you're bored, you're going to start changing libraries in Java, right? They're not going to allow you to go. They hide the most important stuff. Why would you change a double to a character, right? My program can reference either stacks and still execute correctly since both implementation display the same behavior. An example here in Java. So if I take this, I have this public class array list and then public class linked list. This one, and I have this interface, which will have what? Add, get, remove, and size of a list. Okay? Now look, if I want to use this, if I say list string my list equal new array list, or if I call it new linked list, dot add, dot add, dot add, I'm still using the same interfaces. I'm just what? Choosing which data structure I want to use. So this is the kind of the concept of abstract data type. It's like more organizing, encapsulation thing, hiding the most important information. So let's dive a bit more into the details. Now, more formally from the book, an abstract data type is a user-defined data type that satisfies the following two conditions. So we explain everything with examples. Now we're just putting them in a formal, structured way. So what are the two main things? Are the representation of objects of the type is hidden, as we said. So that's one of the main aspects of abstract data type, is the hidden part. So we're hiding our information and we're only giving access to what we decide. The second one would be what? That other programs unit, so the declaration of the type and the protocols of the operation on objects of the type are contained in a single syntactic unit. So what do you mean by that? It's similar to this one. So this syntactic unit here, for example, in this case, it's a class. I'm putting everything in one what? Unit. In this case, it's a class, and then I can what? I can use it as if it's a type or something, and then I can create it. So two main aspects. One is that hidden information. The other one is program units are allowed to create variables of the defined type, which is now I define something as a single syntactic unit. What are the advantages of the first one, which is about hiding important information? Again, we've mentioned lots of things. If you want to think about it, from readability, maintainability, reliability, all these kind of things, hiding, what would be an advantage? Hiding information. Kat. Very good. Okay. If I want to give it like a more formal label, what would you choose? Readability. We have readability, we have maintainability, we have reliability. Readability, for example, readability. But readability maybe for the second one, which is encapsulating them, makes it more readable. But for hiding them, like hiding that you don't have access to them, What do you think, guys? What is an advantage of hiding the, like, don't like make them private, not public? What would be one of the advantages? We've already mentioned it with the car engines. I think you like cars more than you like programming. You just arrived and right away you want to participate. I like the spirit. Yeah.
It's more secure
More secure, definitely. So
from the outside.
very good. So technically, yes. No, but technically, you don't see it. The user don't see it. But you, as a designer of the program, you use it. You have to maintain it, because let's say I'm doing something with the interface is not working. I'm going to go to you and like, okay, this interface is not behaving properly. So you're going to go to this abstract type and try to solve it, fix it. So reliability is one of the main things. This code now is more reliable. Why? Because the user can't just like change them. For example, I gave you an example of changing a double or changing a float. Imagine you're able to change a float and a double. That means your code is not going to be reliable. You cannot say, if I use the int, I'm 100% guaranteed that only integers will work. If this is a public, I say, no, maybe Michael changed it because his application wanted to have something. You know what I mean? So reliability. These are hidden. If I'm 100% sure about the decisions that I make building this class and I made it hidden, I can sleep well at night without my manager calling me. So by hiding the data representations, user code cannot directly access objects, as we said, and then allowing the representation to be changed without affecting your code. Another one is reduces the range of code and variables of which the programmer must be aware, which that's what Catherine said, is that you don't have to worry too much about the code that you need to, as a user, to work with. Name conflicts are less likely. Now, advantage of second condition, you can say maintainability, aids modifiability, because if I have them in one place, encapsulated, right? I can just go there and track them. I can maintain it better. And also, it will be readability. Why? Because they are structured in a very beautiful way. If I want to go and check anything related array stack, I'm going to go to this section. So readability, maintainability, and then reliability for the first one. You see now, if you want to connect this more with other courses, like, because we covered abstract data type and data structure, but we covered it from a different point. We're focusing more on the data structures aspect, about theory, about algorithm, efficiency of time, complexity. But here, we're covering it, but we're looking about what? Design issues and different things. And also separate compilation. This is important. We're going to see it because actually you can compile them chunk by chunk if you want. Now, what are the language requirements for the abstract data type? Again, we covered this a bit when we were giving the examples. We said we need a syntactic unit in which to encapsulate the type definition. What examples of this can be? We're going to check it, and then we need method, right? So the method, we need to decide if these methods need to be hidden or public. And then also we have the primitive operations, which is that's normal thing, you know. So let's take the first one. Let's take this example on the right. What is the encapsulation? What is the syntactic unit that we're using here to encapsulate this program? Class. Class in Java can actually act like an encapsulation device. If I want to encapsulate something, I'll go and do it in a class, for example. Now you can do it on a more basic stuff like subprograms. You can put things in blocks and subprograms. Also, you're going to organize. But here we're talking about more organized way. Why? Because in a function, you don't have to follow a specific thing like in a class, correct? In a function, you can define a function, but it's up to you if you want to return. It's up to you if you want to clean the memory after that. It's all about you. But in a class, it's a what? It's a structured encapsulation way of doing things. You have to follow a specific thing. In a function, it's not very clear for you if you can make something public or private. But here, no. One of the main things of abstract data type that I can hide information. So that's the difference. So in this case, class in Java can demonstrate for us the encapsulation process. Now, what about method of making type names and subprograms headers visible to client while hiding actual definitions? So I need methods. These methods will act like what? Like an access door for me or an interface. In this case, I'm taking this example because there is a different way to do this, right, as method. One of the examples is this way. Public interface, stack interface. So I created an interface and I have a push and a pop, correct? And how am I going to use them? If I have this class array, I'll say, okay, class array implements the stack interface. And then inside here, when I use the public void push, why am I able to use the push and pop? Because I'm implementing the stack interface from here, okay? So this is another thing that I need usually in abstract data type, which is the interface to act. Another example can be used for the people who are taking C++ is header files, correct? What do we usually do in the header file? Sometimes we actually define our class in the header file and we just call it. And we define lots of different things. So that's also another design decision that the programmer, when they designed their programming language, they had to take. Should we have something like a header file? What are the advantages of this? Oh, okay, it's going to compile before the other file. Okay, what is the disadvantage? So that's how they are thinking. Now, if we want to talk a bit about the design issues, what can we have? Three main design issues that they have to decide on when they want to design the abstract data type for programming languages. The first one is, can abstract types be parameterized? So what do we mean by this? We're going to have separate slides for this, but it actually means if they can have multiple data types. For example, would I allow my language? I have a class stack. Would I allow this stack or like these push pop function to work with integers and strings, or no? Only integers, only one type. Actually, if you think about it, it would be much better if you're able to have same interfaces for different data structures. One of them, not different data structures, I mean different data types. But what are you going to change? You're going to change just the parameter. We're going to see it in different slides, but this is a decision that they have to make. Another one is what access controls are provided. Okay, now we're just focusing on the terminology, like the formal terminology. When we say access control, we mentioned it. What do you mean by access control? So inside the function, when we had this, for example, here, what are the access control, Michael?
It's public.
Public or private. So it's another word to saying, do I want to hide information or not? So am I giving access to this array stack like public, or no, I want to have them as a private or whatever. So this is another thing that they need to, that's why some of the languages, they have the protected, some they don't have, they have different definitions sometimes. The other one is the specification of the type physically separate from its implementation? So when is this? Like in a header file, do I want to take the decision of separating the definition of a type and put them in a different file, or do I want to put them together in the same file? So this is another decision that I have to make. So as we said here, many programming languages achieve this through tools like header files, interfaces. For example, in Java, you'll have them as interfaces, but not as a different header file. Now we're going to, in the book, they covered Ada, C++, Java, C#. So we're going to cover mainly C++, Java, and I'll leave some slides of the C#, but I'm not going to overwhelm you with everything. And we don't even have the time to go through every single of them. But in the book, they also add Ada if you want to take a look. Introduction to C++. You took C++, but didn't take C. So technically, C++ is what? Is like a upgraded version of C, correct? So in 1985, an extension of C happen, and why they wanted to do the main thing that they wanted to add upon like on the top of the strength of C is they wanted to introduce object-oriented programming, correct? So they want to add object-oriented programming. So what do they need? What is the main thing of object-oriented? Is abstract data type. So that's actually the foundation of object-oriented, because you have to encapsulate things, you have to do all of these kind of things. So that's why automatically C++ are going to support and work with abstract data types. They work through two things. I didn't cover this here, but in another slide you're going to see it. So to encapsulate, they used class and they used struct also. There is have the struct. I'm not covering the struct here. I'm only covering the class. But there is two ways in C++ to have the encapsulation, not the encapsulation, like the abstract data type, okay? And then the class is a type. So when you create your class and you create an object of this class, then you'll have a new type, okay? For example, a new type of called stack. The same way you have int, you have float, you have. So let's take a look. We said there's encapsulation and there is what? Information hiding. So let's take a look on both of these. In this case, what is the encapsulation here? Again, similar to the example that we gave. In this case here, it's a class. So the class is acting like an encapsulation device. What does the stack class encapsulate? If you go back to the first slide about the trading stock, we said you need two main things. Michael mentioned operations and methods. We're going to cover them. What else did we say you need? Data. So the first thing that you need to encapsulate, or like what does the stack usually class encapsulate? Data members. It's called data members. In this case, what are the data members? Yes.
Verbs.
In this example, exactly, mention them. What are the data members here? Like, so name them. So the stack PTR, stack pointer, max len, top pointer. So these three are the data members in this case, correct? Very good. What are the methods now, the operations? So we have push, and then the other ones, we did define them. We have push, pop, top, empty. Two things always you need to encapsulate are the data members and methods. You need to differentiate between these two formally. So we have push, pop, top, and empty operations to manipulate the stack. Good so far? Okay, what is the other aspect of an abstract data type? Information hiding. So let's take a look. In information hiding, we have two parts. I need to decide the hidden part and the public part. In this case, the hidden part is what? So only the necessary information is exposed through the control interface. What are the hidden part? They are the private. As simple as that. That means in this case, these here are the hidden part. Now, stack, pointer, max len, and top sub are declared private. So what will happen if I'll try to access one of these? Am I able to? No. Meaning they are not accessible directly from outside the class. Example, a user cannot directly modify top sub or stack pointer. Now, if you think about it from a practical perspective, what is a stack? Stack will have a bottom and a top, correct? The top will be what, usually? What is the top and the stack? Very good. The top is the last element you added inside the. So let's do this. So this is the stack, and I'm adding things. So I added, for example, 5, I added 7, I added 8, I added 10. So what is my top here? 10. Now, if I allow users to manipulate the top, in a stack idea, the idea of a stack is that the top will always be the last one. You cannot manipulate it. So if I allow Esad to manipulate this, and he was bored, and he had lots of free time, and he wants to play around with this. He said, you know what, I'm going to make the top 7. I just want to see what will happen. What's going to happen? There will be no error, but everything will be wrong. You destroy the application. So if you allow the user, so that's why, guys, here, necessary information is exposed. It's not like you looked at things, you know, I'm going to do this public, I'm going to do this private. No, you have to follow the idea of necessary information. The top is not a necessary information for you to change, but you need to be able to use, you need to be able to look at it, use it, all of these kind of things. But how do you use it? Through the pop. You do a pop, you're going to be able to use the top. But you shouldn't change it. You're destroying the whole program, like the concept of this program. So you get the idea. So that's why there's a hidden part. Now there's a visible part, which are usually defined under the public, because it's necessary for you, if you're using a stack, to be able to push and pop. I cannot give you an application of a stack and you're not allowed to push or pop. Okay? So in this case, are placed in a public clause, push, pop, top, and empty are declared public. They act as the interface. Again, the word interface. This provides controlled access to the stack. Why is this important? We've mentioned this so many times because this is going to be, by hiding the internal details, we protect the data from being corrupted or misused. Okay, now people looking at this, who's taking C++ here? Okay, so they are saying, you know, Professor, with totally due respect, this is the wrong example you're giving us. Or you didn't study yet for your C++ final and you didn't notice anything. So what is the problem here? What's missing in this code? There's something missing.
Sorry, missing for?
There's something missing. In general, when we use a class, when we define a class, we have to include something in the class. Yes, Isa.
Constructor? Constructor.
So that's, do you see here, we're talking about the design issues, like what's the differences between Java, what's the difference between Java and C++? One of the main thing here, C++, we need to now do the constructor. But I skipped it for here because we'll have a separate slide for it. So I added the constructor here, and let's take a look. I don't think I have time to copy this, but let's assume I copied this into the online compiler, and you can do that. Now I added the constructor stack, we're going to talk about it, and we did the stack, my stack. If you noticed here, because I defined this as a class, now it acts like as if it's a type, okay? That's what we mean a class is a type. As if I'm saying int x equals something. So stack, my stack, what's happening here? I created the object of this class and I'm saying my stack.top sub equal 5. So what's going to happen? So I'm trying to access, where is the top? This top sub should be top pointer. I'm going to have what? Error. Again, abstract data type, you said we need to know what's the data, methods, but also we need to have the error handling. It's important. And that's the difference again. Yes.
Just to make sure the data members are just the variables inside.
Yeah, data members are whatever you want to store inside this data structure, whatever you want to have in the class. Data members, the data variables. Okay. In this case here, even the pointer that you have, which is you don't use directly, you use indirectly, is a data member. So any variable inside this class. So here is going to have an error, not allowed because top is private. And actually, if you copy it and try it on the compiler, you're going to have a top PTR is private. Now let's go and take another one. Here, I'm going to be, I want to do the push. The push is in public. That's the push. So I should be allowed. But if I don't include the constructor and the destructor that I just mentioned to you, if we do this here, I put them because I wanted to copy it and make it work. But here, let's say if we don't use the constructor, what will happen? Who can tell me, again, because you're taking C++, there's usually 2 options that you may encounter. Who remembers? I'm helping you study. for your C++ class. If you don't have a constructor, what will happen? Yes.
Variables are assigned to any values.
So none of the variables here, because here we have these, correct? So these variables are not initialized. So there is two options usually if you try them. Sometimes this is going to give you an error that these variables are not initialized, it's not going to work. Some other times, because technically, when you don't do the constructor, it will give them random addresses. It's going to give them random values sometimes. So sometimes, by mistake or by coincidence, the top pointer here and the max len, they're going to be assigned randomly the same one. So you're going to enter this and you're going to have this error in push stack is full. So sometimes either it's going to work but misbehave, or you're going to end up with an error. So constructor, when it comes to C++, it's essential when it comes to classes, because you want to construct. Why? Because when you construct, you want to initialize these data members that you have. So that's my initialization. Now, a constructor is a special function in class that is used to initialize objects when they are created, and it is automatically called. So you don't call the thing. Whenever you just create the object, you said stack equal my stack, then it's automatically called. In this case here, because this is a stack pointer, in this case, just in this case here, we have this a pointer. So what's going to happen? This is going to allocate memory. Where? On the heap, because we already covered this in the data types. We said in the C++, if you're using the pointers and stuff, and you have to use the new and delete, this is going to be allocated on the heap. And then you're initializing these two. So there's three main things for the construction initialization. When an object of class is created, the constructor automatically initialize it. The second one is memory allocation. So in this case, if we need to allocate memory on the heap or whatever, it's going to also play the role of memory allocation. And the third one, which is a third characteristic, is its implicit call. That means you don't have to invoke, you don't have to call it, even though you can, but you don't have to. So this is from the book. In a formal way, functions to initialize the data members, allocate storage if part of the project is a heap dynamic, and implicitly called. And name is the same as the class name and all these things. Okay? Now, what about the destructor? The destructor is also implicit. It's going to be automatically called when this is done. So you have the constructor called, and then this is the destructor. Why the destructor is needed? We covered this in an indirect way in previous chapters. Catherine.
In C++, you have to manage memory manually.
Beautiful, exactly. We've covered this data type. We said one of the main issues, main like design issues, if you want to call it, that it gives you better flexibility when it comes to allocating and deallocating memory for C++. But what is the overhead? What is the disadvantage? You have to do it manually, so you have to destruct them. That's why if you don't define the destructor, it's not going to destruct the memory, so you want to free the memory from the heap. Yes?
Well, if in your class for C++, you don't have any allocation or deallocation of the like variables or anything like that, is the destructor really needed? Because
No, but usually you want to always have it as what? As a, what's the word, like as a good practice, or like, because when you want to do something, you want to do it that works for everything. What if in the future you decided to add a data member, but you forgot to add a destructor? No, so every time we have a class, it should have a constructor destructor, but it will work if there's nothing to destroy, it will work. Because even without the constructor, as I said, it may work, but it misbehave. So clean up after an instance. So that's the main thing, usually just to reclaim the heap storage. So the idea is I want to reclaim this storage, and then can be explicitly, and then the difference between the constructor and the destructor is this. So that's how we define them. If you look here, you're going to see that that's the only difference between a stack and a destructor is this. And what are we doing? We're saying delete this stack pointer after you're done. Now, What are header files? We mentioned the header files. If you remember, we said it is part of which main thing? It's the interface thing. So let's say it's another way, or we're answering which design issue we're answering. Are we going to allow this programming language to have a separate, like a physical separation between the defining things? So header files are closely connected to the concept of abstract data type. They play a crucial role in separation of interface and implementation. We said the ADT focus on exposing the interface and hiding the implementation. So header files in C++. So the header file provides the interface. So let's see it. So this is inside the stack.h. I'm going to define it here. But then you define things, you say the void, and everything, but you still in the .cpp, in the main file, you still need to what? To put everything inside these functions. Okay, but this will be compiled separately from this one. So that it's a way for C++ and to have this separation between the two. Now, it will not work if you don't include this. Even if they have the same name, the machine will not say, okay, stack.h, stack.cpp, it will work. No, you have to include it. So you have to have the link to them. Yes.
Can you do the header in the original file? I remember there was a way if you just put like all of that at the very start.
Maybe this will be a question for the professor of the one who's teaching the C++ class. I didn't go.
It's because he actually didn't show us headering at all.
You didn't cover headering? Okay, so that's what we usually do when we're tracking big files and stuff. That's what I usually do in the company that I used to work with. But I'm sure there is a way.
The only reason I know is I like did some stuff.
Yeah. Most probably, if you just do these things, and I think we showed something like that when we gave the example of prototype and not prototype. If you delete the declaration from you remember? We said if you delete the declaration, it's not going to work. So technically, you can just take these as declaration without the header file. But the idea of the header file is that it allows you, so the decision made in C++, I allow you to separate them, but you don't have to. Now I remember that we actually tried it and we had declaration, but not for classes, for normal functions when we were covering subprograms. So now I want to jump on the Java example quickly before we move to the other things. So what is the main difference between the two? So let's take a look. All user-defined types are classes. We said in C++ it can have structs or classes. When it comes to Java, they are all what? Only classes. So that's how you do ADT. The heap allocation, this is very, very, very important, guys. So this is one of the most important things. Focus on it a bit. We've mentioned this again previously in the data type. When I told you, even if you're defining an array inside a function, even if the array is local, where is it stored? On a heap or a stack memory? You remember we got that even in the quiz, we had this question. Samuel, Java. Heap, we said all the variables that they are local, they are going to be on a stack memory, except arrays. Even if it's local, it's going to be in the heap. And then we said, why? Why this? Samuel, because it's an object. We said arrays are objects, and objects are always on a heap. That means we should know this. Classes and objects. That means all the objects created from classes are going to also be heap allocated. But that's not the case with the C++. C++ is different. C++, if you do this, stack my stack, it's going to be created on a stack memory. When you're done from the main, it's going to be destroyed. But if you call it like this, and then you didn't new, even if you're using the same stack, okay, this is going to be allocated on the heap. Now, don't confuse these two, because even if the object is allocated on a stack, if you have something inside here, for example, inside the constructor that has a new, This specifically, just the pointer will be allocated on the heap, even if the object is on the stack, okay? So these, because not all the constructors will have heap allocation. But we're saying, what we're talking about now at this point is the object itself. So the object can be a stack or heap, but when it comes to Java, all objects are located on heap. Now, this simplifies memory management and ensures consistency as objects behave the same way regarding lifetime and access. Now, access control, another difference is what? When it comes to C++, you have to put them in sections. For example, you say public and all the public under it. Private, all the private. In Java, no. In Java, you have public, void, private. So it has to be individual, okay? So that's one of the other difference. Now, garbage collection is one of the most important or most obvious. One of the most obvious differences is, do we need a constructor and destructor in Java? No. We said there is a garbage collector. Whenever you create an object, if you're not using it, it's going to be what? There is a garbage collector will take care of it. So that's why now we're connecting concepts together. We covered this so many times, but we've never mentioned the word constructor and destructor. Now you're actually just seeing the actual differences when it comes to the languages. So a garbage collector will be here automatic garbage collection, but with the C++ must manually manage memory. This makes Java less prone to memory leaks. So if I ask you a question, which language is less prone to memory leaks, Java or C++? You need to know that it's Java, of course, because of the garbage collector. Now, this just side by side, you can take a look. We don't have much time. This is also a summary of things. We just put the summary of what all the stuff that I talked about. The C#, I left 2 slides for it. We're not going to go through it a lot, but the same idea with the C#. Do you remember when we said we wanted to make C add more like more functions to it, so we made it object-oriented. So it started. Now the C#, they added more things on the C++, and they have a garbage collection now with the C# also. So they improved kind of like, so they took the strength of C++ and they added more things to it. So there is the class instance are also heap dynamic, garbage collection. There's other things like getter and setter. You can take a look on them. Now, parameterized abstract data type, very quickly, we mentioned what do you mean by parameterized? This is one of the design. Would I allow my class to be able to cover different data types? So let's see a quick example here. So they are also known as generic classes. If you've heard the word generic class, that means this class will cover more than one thing. It is supported C++, Java, and C#. All of them, they support this. So let's take a look. Here, in this case here, I'm saying my stack int size, stack pointer new int. So when I define my class, I'm saying it's a new int. This stack can only have integers, okay? So if I do this, it has to be integers. Now, how can I improve this to make it parameterized? Usually, there's something called class, templated class. How will we do this? We're going to say class type. So class type. So now, you're not saying new int, you're saying new type. So whatever I put here stack int, it's going to be int. If I put stack string, it's going to be string. So you're able to call it like this or call it like this. So this is a very powerful way to actually use the same interfaces and the same class for different types. It's as we said, it's also supported in Java. But what is one of the differences in Java is that C++, you can do direct indexing. It's also similar to some of the data types. C++, they love direct indexing. They always include these things, even in the enum and everything. So here, for example, if you have this my vector, you can just say right away 0. When it comes to Java, the preferred way is this. You create your class here, you have to get it through a getter function. So that's one of the things. So again, the same thing, a template, it's T here, you're passing T, and then string or that, yeah. So you put string, you decide it's string. Again, I put the main differences. Here you can right away in C++ include the primitive, but here you have to do this. And then we say multiple types, and what else? The indexing support, direct indexing here. and here we don't have directly. Now, very, very quickly, encapsulation, because we're going to use this. We're going to end here and start with object-oriented. We say object-oriented is based on encapsulation and all of these things. So large programs have two special needs, usually some means of organization other than simply division into subprograms, some means of partial compilation. So instead of just having so many subprograms, you can just do the encapsulation. That means I want these 4, 5, 6 subprograms to be together and compile together. This is better than just having so many, because we said subprograms will help you a lot, but not enough. Obvious solution, a grouping of subprograms that are logically related into a unit that can be separately compiled. We call these encapsulations, which is what include. Now, nested subprograms, do you remember when we said what is a nested subprogram? You define something like this, blah, blah, blah. Inside this, you define also this. We covered it. Not all the languages support this. We mentioned one of them last time, which is Python. You remember? Python and also JavaScript and Ruby. Okay, but I don't think you can do that in C++, nor in Java, nor in C. Now, encapsulation in C, before going to C++, files containing one or more subprograms can be independently compiled. The interface is placed in a header file. If you place your interface in a header file, that means the header file will compile separately than the .cpp. Now, one of the problems, so the problem one is the linker does not check types between them. So this is a thing. I think Java is better when it comes to type safety, if you remember, even when dealing with other types. So when it comes to type safety, Java is in general better than C and C++. In this case, what will happen if you define something in the header file as void display and it takes an int, and then in the in the actual file, in the CPP file, you say void display float x, it will not catch it in the compile time, because it compiled this separately and then this, it will not catch it. So it will only make the error when you run at the runtime, not at the compile time. So the compiler will compile both files without error to solve this. That's why we have the functioning prototypes. We're not going to go through this. I'm sure that you covered this and we mentioned it a bit last time. So these are the function prototypes will protect you from having these issues. The other problem is the inherent problems with pointers. We're not going to cover this also, but you know that there's lots of pointers. You need to keep track of the pointers and all of these kind of things. And also, if you forget to do the include, you're not going to connect the two files together, right? You have to include the header file to be able to save them. Now, encapsulation in C++ is the same as the C, but we added on top of it, the classes can be used for encapsulation. Not only like, for example, you're defining things in the header file, and the header file is acting like an encapsulation. We also have classes. The class is used as an interface. We mentioned all of this. There's something called friends also. And that's it. Thank you. On Wednesday, I'm going to create, we didn't have time to do the WOOC lab and stuff. We're going to put them, practice them for next Wednesday. Okay, guys? Next Wednesday and Friday, last chapter, object-oriented, and you'll be ready for your final. On what? It will be on subprograms and subprograms implementation and this one.
Wednesday, bro. Last day. Next week on Wednesday. That's fine.